NG7M Max, yet again, you must be back for another exciting video as we continue on with the calibration of an RF-KIT B26-RF2K plus amplifier kit. And so if you found this video before my other calibration videos, make sure and check the my YouTube channel, which is NG7M, and catch up on all the previous videos. So I'm going to move right along here. The previous video obviously covered steps 6 through 9. We are going to do steps 10 through 12 in this particular video. And just thumbs up and to Reinhardt, Chris, Canute, and Mark for their efforts, and anybody else that's worked on the project here. This is my opinion, and I own all the mistakes in this video, so you have been warned. Please read the latest documentation and understand that I made these videos in mid-August. It's the 23rd today, or somewhere around there, the 24th today of August 2018. So you want to double check all the documentation, double check everything I do here. This is just a good reference to show you kind of an overkill of going through the calibration. So one call out again to Canute. I know in a couple of the other videos I was crediting a previous ham that was working on the software, but Canute has been working on the software here for going on 2 years, I'm told. I just found an old reference. So shout out to Delta Fox 9 Quebec Alpha DF9QA for all his efforts on the software. So keep it up. It's very cool. The coding there on the display manager, what you see on the screen on the front display, or when you're remoted in via VNC. So with that, let's move along here. Make my image small, and we're going to get right into step number 10 here. You can see on the screen. And step number 10, the controller boosts the SWR reflected voltage so that fine adjustments are possible by the antenna tuner at low power levels. And this particular test, or a calibration rather, will require a 25 ohm load. So I'm going to turn my video off here and keep the audio on, and let's hook up this video right here, and I'm just going to go up to the top here and show you the dummy loads again. So this was covered in video 3. We've got I've got a T connector here. You're just putting 2 dummy loads in parallel to, instead of a 50 ohm load, as far as the resistance is concerned, you're going to get a 25 ohm load. And I'm not going to take the time to show you that this is 25 ohms or very close. You'll be able to see the SWR when we drive the load here be around 2. And so that needs to be the reference here when we make this adjustment. So I just hooked up the dummy load there to the transmitter 1 output on the back of the amplifier, and we will be using, let me pull that screen up here, we will be using R17 for this particular test. Off the top of my head, let me double check that. R15, sorry, I'm jumping ahead here to the next step. We'll be using R15 right here. If I turn off that video, so right here we will be adjusting R15, and I actually did I think I'm going to be really close in the ballpark because I did some testing before this, so you'll see that in a second. So R15 it is, and we'll get that other video back on right there. And we need to pull up the VNC software, so you can, as though you're looking at the front of the front panel. It's a lot easier to do the calibration with the front panel off and just remote it in with VNC. And I have the cat going. We're on 7 megahertz. And quick comment on that, I noticed, and for this one you need to be in standby, not operate. So if you follow the instructions, they're going to be in standby on this particular test, okay? So I'm on 7 megahertz here. We're hooked up to a 25 ohm load now, and so we're going to key the transceiver, and let me pull that power meter up here, and I need to move things around here so we can see all the good stuff. I'll just put that over there. I'll do a better job than I did in that last video. I was covering things up. I don't think I missed anything, but I was covering a few things up. So, all right, we're going to go to the menu on the amplifier and then go to the debug screen. And as you can see back here on the manual, we will be looking at the Alpha 1 power tune gain right here. Alpha 1 power tune gain. And I'm not going to zoom in. The zoom in, it just makes it hard on me. And I looked at the last video, and you should be able to still see this value right here. Anyway, Alpha 1 power tune gain, you're going to adjust to a value of 600 with 10 watts and we should be able to see approximately a 2-to-1 load here. And so I'm going to key up the transceiver, and you might take a little more than 1 watt there to kick in on the LP700 before it starts showing the correct SWR. Incidentally, the LP100A is much more accurate at lower levels than the LP700. Just a bit of a digression there. An LP100, the digital vector watt meter, a shameless plug for Larry Phipps and LP, but an LP100, if you're really into QRP, that's the watt meter to get for low power. So we're going to go up to 10 watts output on the LP700, which has been my reference. Ooh, and it's right at the threshold of kicking into the main amplifier on my K3S. So we're gonna stop it right there at 9.8 watts on the LP700. I'm beginning to wonder if that LP100 is maybe a little more accurate. It's showing 9 watts, so close enough here. That's actually still very accurate. So now you can see on Alpha 1 power tune gain, you can see that the value is at 572 or 3, and I thought that was going to be a little closer. I couldn't remember. But now we're going to delve in there to, again, R15, which, wow, I have a short memory. R15, I just pulled that up so I can see it. There's that upper left quadrant there. Minimize that. And you'll see me get in here. And you should see that value change just immediately as soon as I start tweaking the R15 here. So if I get my cursor over here again, we want R15 up to a value of 600. And sorry, it's a little tricky with my cross-handed technique here. So there we go. It's right, flickering right around 600 right there. I mean, I could quickly zoom in. So we're right around 600 on Alpha 1 power tune gain, if that shows up. I don't know about that zoom thing. So I'm going to unkey the transmitter now and minimize that out of the way. We're going to close this. And again, we needed to be in standby for step 11 there, or step 10. Step 10. And now I'm going to claim success on step 10, and I'm going to the new combined manual that K3NC, and I don't think the previous manual shows it either. I think this is the only step now where you use the 25 ohm load, and so it doesn't say to switch back to the 50 ohm load, but it's clear, right? It's common sense that in the next step we're going to be driving the amplifier with 100 watts, and let's get back to the 50 ohm load. And I left the video of, hey, you got a section there without me in the lower left hand corner. So let me switch back to the 50 ohm load up here, and trust me, I'm doing that. You can hear me making the change up there. All right. And there's a picture of me back on the lower left-hand corner, because that's, I'm sure, what you want to see. All right, so the amplifier is in standby. We're on 7 megahertz still, and we're back into a 50 ohm load, and the transceiver is not keyed. So let's move on to calibration step number 11. And so this calibrates the controller monitoring the power level at both the low-pass filter input and output. And so if there's a crazy discrepancy there, this is a safety thing, right? It'll produce a critical error. And so this protects the amplifier from a fault in the low-pass filter board. If something goes crazy there, if the input voltage and the output voltage are not what they should be, you know, within whatever the parameters are of the controller, it'll air out. So the calibration of this function is accomplished by adjusting the level of the built-in power detector circuit on the low-pass filter is displayed on the debug screen. So I am ready to go here, just looking at the steps. I'm ready to go with the transceiver set to 7 megahertz, just kind of down there, you know, a little above the low end of the band. For this test, we put the amplifier in standby because we are going to now send power through the input and the output of the low-pass filter, and it'll actually obviously be going through one of the filters, the 7 megahertz filter in this case, and we'll be adjusting R17, which is this pot right here. So on the right side of all those pots, it's the fourth one down from the top there, R17. So I'll get that out of the way here. So for this little test, we drive the dummy load at 100 watts. So I'm going to key up the exciter, the transceiver here. We're going to kick this up to 100 watts output. And you can see I'm back on the 50 ohm load because I have a 1-to-1 SWR there. And here's one thing I wanted to note here. Now that we're actually, the RF path is going through the low-pass filter, you'll see, don't be surprised if you see a little bit of different SWR, right? So now you're going through those low-pass filters and the impedance might be a hair off. And I even noticed on the 20 meter filter, I was seeing a 1.35 to 1 SWR, and you know, that may be within spec, but I mean, it doesn't have any very, I mean, if you're under 1.5 to 1, but it did kind of raise my eyebrows. It was like, wait a minute, I should have a 1-to-1 load, or a 1-to-1 SWR with this 50 ohm load, but I didn't take into consideration, since I was in operate, right, I'm going through that low pass filter. So you might see a little difference on the SWR reading on your meter when you're going through the low pass filters. The 7 megahertz filter is, you know, 1-to-1 here, according to the meters. It's actually 1.05 to 1 on my LP 100. Okay, so I'm heating up the, we need to take care of this and move on here because I've got the exciter keyed somewhat hot here. So now we're going to look at alpha 2, right? And let's see here. Let me just, I'm going to unkey a minute again and just double check things yet again. I just want to sure remember R17, R17, R17. Okay. And we want to show a reading at alpha 2 power PA module out of 100 to 160. So I'll put it like at 155, put it in the middle there. So again, operate. We're on 7 megahertz. Everything is good. Back to the debug screen, and it's going to be alpha 2 right here. So I'm going to key the amplifier, or the exciter, and we're going to get that drive back up to a juicy 100 whopping watts here. And that's pretty close. This must have been one of the pots that were turned down. And it's this pot right here, R17. I don't have that screen up. I guess I could show that screen. Oh, I do have it up. You can't see the power meter. I got to keep track of all these screens. So now you're seeing me going in for R17, which is the fourth one down on the right side of all those multi-turn pots. And we're going to adjust alpha 2. And let's see here. I can't remember if it's clockwise or counterclockwise. Oh, it's clockwise. So in the pre-setup we were adjusting it all the way counterclockwise. So now you can see right here, let me do my crossover technique here, going up to 100, and I'm going to do 155 because apparently so right there. So now we're at 155 right there, and I'll do the zoom in. So alpha 2 power PA module out is at 155. And I'm going to get that exciter turned off. So, all right, exciting. Here's some commentary on this particular step. I'm going to see if we can just kind of keep all three of these screens on here at the same time, close to it anyway. Okay. All right, just adjusting the screens there a little bit. Okay. All right, the last bullet on step number 11 here is like messed up. This doesn't make sense. If your transceiver will not go low enough, which I think should read, if your transceiver will not go high enough to produce 100 watts output to adjust our, for that A2 power PA module output. This last bullet is related to making the same adjustment when you have the actual RF palette or the RF deck hooked up and you're driving the amplifier at with power. And so when we come back, this last bullet will come back with the high power calibration. You go through some of these steps with the high power where we, right now we have it bypassed, and we'll adjust R17 for a reading of 425, or make sure it's kind of in that ballpark, because this text is not reading right. I've noticed that anytime there's an alternatively word, that means it's like optional. So I'm not sure if that's for high power adjustment or if it's just an option based upon if you've already hooked up the power deck output. Anyway, some commentary on there. Hopefully the manual will get some clarification there. All right, so let's move on to step number 12, and that'll be the last step for this video. Now this step is interesting because here we are going to set up a calibration that trips the protection in the amplifier when the drive power hits a certain level based upon the controller detecting a specific voltage. And so what's going on here, and again, this is where you need a fairly accurate power meter. I keep beating that, hopefully not dead horse, but we need a decent power meter here. So what we're going for, the controller is looking for at 1.9 megahertz, it's looking for the voltage of 1.5 watts, I'm assuming. And so if you read through the instructions here, the first thing we'll do is we'll put the transceiver down on 1.9 megahertz, and you can see I'm spinning the dial right over here. You can see it get up to I'll just put it right on 1.9 megahertz. We're into the 50 ohm load. Okay, so now we're right at 1.9, and then we calculate the max drive power that'll produce 1.5 watts at the endpoint, or at the input, right? So I'm using a 13 dB attenuator. That's typically the one that comes by default here in the States anyway. I have the other two attenuators, and I think some guys are wanting to actually have a little more attenuation, which I need to comment on that. If that's the case, you need to come back to this step and recalculate here, and or do the whole, or not calculate, but calibrate, or do the whole calibration again and make yourself feel good. But I will be driving 30 watts, which should give me 1.5 watts out to the output that normally would be going into the RF deck, right? So for this, we're going to use R2, and I'm sure I'll show you R2 down here. It's on the lower right-hand corner, R2. I'm going to try to remember that, not have to pull this up again. And this is a little bit tricky here. And so let me bring this down here. We're going to zoom, hopefully get in a little bit more. Right here, I'm going to make this big. Because to test the voltage here, we're going to tune R2 so it's close to tripping at the right voltage. And so we're going to drive, in my case, I'm going to drive the amplifier with 30 watts because I have the 13 dB attenuator on the input. And I'm going to set the voltage measurement to 2.5 volts at pin 5 of IC N1. Okay, so let me pull up the screen here. So, and man, I'm good at having the wrong screen size here. Okay, so back here we're looking at this integrated circuit. Okay, so earlier models of the PCB, you would have to tap into the 5th pin. Here's pin 1, 2, 3, 4, 5, okay, right here. But on later versions of the PCB, which I have, you can also use this pad down here. So right below the integrated circuit, there's a pad right here, which is still not very convenient. So little nitpick there, it'd be nice to have a test lead here, or a test header at least right on that pad. But this is much better than what was before. What I did was I soldered, and you can see in other pictures I have, I think I've got another picture that shows that wire. So yeah, here, this is good. So what I did was I soldered a test lead on to pin 5 here. And so that's what I'll be using. But you can see down here I call out the fact that now that I know about this pad, which I found out after I soldered on the test lead, so I'm not using the pad, but they're just tied together. That'll make it easier. So I'm going to hook up a voltmeter, a digital multimeter, and DC voltage to this pin and ground, and we're going to measure. We're going to get the R1 pot in the ballpark to trip the protection with 30 watts drive in my case. Hopefully that made sense. So, okay, back to the video of the front of the amplifier, and I wanted to get in a little ways here. Oh, I said R2. I said R1. It's R2, 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 like R2D2, and I don't know why I have such a hard time with that. So let me go back there, and it is R2, the top one, the top pot. Okay, let's see, R2, just to get it in the ballpark. It seems like a lot of effort to get that in the ballpark. There's an alternate method there. You can just give it 5 turns, but this will, I think, get us a little closer. So we're going to be using this, hitting that pot right there. And so I'm going to hook up, I'm going to turn on the my voltmeter. Now I got to turn on another camera, and wow, there's a lot of cameras here. Okay, and so I've got just my clamp-on leads right here. Whew. Okay, and so this makes it a lot easier. I'm tapping into pin 5 there. Okay, right there on that little test lead that I'd soldered on, and I'm gonna snag a ground spot here. Maybe there's a better one, but I'm just gonna take this pin on that integrated circuit because I know that's ground. And right now I don't have anything keyed right now, but it is reading. You can see on the digital voltmeter it's showing 2.5 volts. So okay, we're set to 1.9 megahertz. I'm just going back to the instructions again here. Okay, I think I can make this small again. I've got that hooked up. Blah, 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 blah. Okay, so this is before you key the transceiver, so that makes sense now. We're just adjusting the voltage to get the pod in the right spot. So Okay. So you can see the voltmeter there. It's high right now. You can see that it's showing a little high there. We want to drop that down, so I'm going to go down to R2 here carefully because it's kind of in the way of my test lead, and we're going to adjust that voltmeter down here, and I'm going counterclockwise. Saw it change. So we're going to go down to 2.5. Now if you want to be conservative and trip the amplifier with less drive input for the protection, the documentation or the calibration instructions show that you want to go a little bit lower there. So I'm putting it right at 2.5 volts, and that'll get changed again anyway. So now we know that that's at 2.5 volts to get us in the ballpark, and I'll leave that on there just so we see what voltage it ends up being for 30 watts drive. Okay, so now I'm down towards the bottom here. Let's make this smaller so we'll kind of get everything on the screen here. Okay. Okay, I want to select operate on the amplifier. So we're in operate mode. And so I'm going to key the amplifier, and this is, you want to understand this right, because now we're going to find out a threshold by changing R1, which is the lower one. So we're going to be changing R1 to set the protection threshold for 30 watts. So as soon as I hit 30 watts, I want the amplifier to go to kick off the transmit, right, and it'll go into an air state, right? So the protection will kick in. So I'm going to key the amplifier. You're seeing the watt meter there, and as I get up to 30 watts, if it trips right at 30 watts, it'll be like happy day. So I'm just going to crank it up here. So just depending on if it trips too soon or if it trips too late, that's how we'll adjust R1 to get closer to 30 watts. See, so ooh. Wow. So I'm clearly not even close there. So I'm going to get it back down to 30 watts here. And I think in this case, so let me get it down to 30 watts drive. 29.8 is good enough. So I need to turn R1 clockwise until it trips. That's what it looks like to me. So, and we'll keep all those on there. So we're still at 2.5 volts as adjusted with R2 right above here, but now we're on R2. So we should see a protection error pop up here. If I just get right below, maybe. Oh, right there. So I just hit, right? So now this requires a little commentary too. There's been some discussion about this on the forum, that there's a problem with the reset here. But I've noticed if I have CAT hooked up, I don't have that problem. So I think that that particular little workaround where you had to key the amplifier is not required if you have the CAT control hooked up. So when you hit the protection, you don't have to worry about that. So again, another call out to have your CAT control hooked up. And that also worked when I was testing with the RF bridge too. So this is the full pulling CAT control to my K3 in this case, but I didn't have to deal with that little tweak where you had to key the transceiver to get it out of the protected air state. Okay, so now we're back. I've reset right. I'm back in operate, so we're going to key the transmitter, and we should see that air state very close to 30 watts of drive. So now as I get up here, get up there to 30 watts of drive, we're getting closer. Ooh, so it's triggering a little bit soon, right? So now I need to go counterclockwise a little bit. So I unkey the transmitter. I'm going to hit reset, leave it in standby. And so I'm going to go a half turn out on R1, okay? You see me getting in there, half turn out on R1. And we'll go back to operate. I'm going to key the exciter again and drive it up to 30 watts. And so we're looking for that 30 watt trip level. So right as I get to, I think 26, 27, 28, 29. Oh wow, man, that half turn did like a lot. It took like 40 watts drive that time. So unkey the exciter, reset, okay. I'll leave it in standby. I'm going to go clockwise again, maybe about a quarter of a turn or so. And so there's a little bit of trial and error here to get that set in the ballpark. You know, and if you want to be a little aggressive, you could set it a little higher at the 30 watts. But let's follow the manual. Okay, so we're going back to operate. Get that drive level up here. And okay, so there's 29.9 watts drive. If I go, ooh, so now it's tripping, you know, right at like 34 watts. So I mean, this is getting really pretty anal here on the adjustment, but boy, it doesn't take much. Okay, so I'm going to turn it just a hair there, and we'll do it one more time and call it good. So I'm going to reset the protection on the amplifier. The exciter is off, operates on, back through the same old routine, right? And it should trip right very, very close to 30 watts of drive. 29. Boom, right on the money pretty much. Assuming the LP700 is accurate, right? But we're close there. I'll reset. I've got the exciter unkeyed, and I think I've covered everything there. We're done with this video. So we've done 10, 11, and 12. There's 3 more steps to go, which will be in the next video. I hope you have found this interesting, and look for another exciting video here coming up. I'm sure you'll be waiting on pins and needles for sure. So once again, this is Max, NG7M. Hopefully you enjoyed the video, and give it the thumbs up. Take your time and leave comments if I really jacked something up in the calibration. I think I did a pretty good job there though. And I'll get this video uploaded, and we'll move on to the last 3 steps of the calibration. So we're getting there. I think that is about, oh, hey, one thing just to remember, I don't think I talked about that in this video. I remember back in calibration step 7, there are comments in the calibration manual that you should see the lights coming on the RF palette. And when I was talking about that, I don't think I had the amplifier in operate. So I was like keying my exciter, but I wasn't seeing those LEDs on. But if the amplifier was in operate, you'll see those LEDs come on, one for each LDMOS device. So just a bit of a digression there. So 73, thumbs up everybody, and we'll see you in the next video. All right, 73, bye.